Hello and welcome back. My name is Corey and you're my rubber ducks for the evening. And I'm sure somebody's watching this saying, why does he keep on calling us his rubber ducks? Google it, rubber duck debugging. Anyway, it's fitting for this series. Anyway, this is the series where we are creating a programming language from scratch in C++ using a terminal window and Vim as our editor and things like Flex, Bison, Google Test, ICU, and just going at it. Doxygen for our documentation. I don't think I normally say that, but we do use Doxygen. And let's see, a couple things that I do starting out. Always make sure we've got a fresh compile. So make test watch. All right, and now on the left-hand side, what are we going to do? First of all, we normally show git log. The last commit that we made was episode 84, so that means we're on episode 85. And if I say git status, you'll see that no files have been changed. That's right, I say there's nothing up my sleeves. I don't have anything pre-prepared. You're seeing me 100% live coding with all the mistakes that entails. Yes. And we are continuing on our bytecode optimizations. That's what we're looking for. And well, let's just do this. Let's jump in. First of all, if we look at our include Tang, this is where we listed our optimizations. And then if we also edit our source for program, which one is it? Optimize. Yeah. Those are the two that we need. So what we did last time was actually this optimization right here. And in fact, we're just going to put that in place down here and say optimization number, well, number 3. All right, so this is an optimization. Yeah. And we're about to do we're going to do optimization number 2. Wait, do I want to do that one? Yeah, why not? Oops. Okay, I messed up. There. Oh, evidently Shift-I is how you go to the first of the line. I need to remember that. There we go. And we're going to write this. And you know what? We're also going to write kind of a little helper thing that says bool changed is equal to false. Nope, actually. We'll do true and we'll say while changed. We're going to put all of this inside of there. And if we had to remove opcodes right here, we'll say changed is equal to true, but the very first thing we would get here is changed is equal to false. Evidently I can't type. All right. So change is equal to false. Oh, we changed something. It's true. So we're going to go through and see if we can, because there's at least 3 different optimizations. So basically, we're going to try to apply all the optimizations, and then if we change the bytecode, that means we might be able to optimize it again. So that's the idea. And actually, let's just save this and make sure that all of our tests still pass. Might as well. They do. That's always a good thing. All right. So how are we going to do this? Well, we're going to say for size t of I is, and we're looking for 3 sequence pattern, poke, pop, and then peek. So I is going to start off on 2. I is less than ops.size plus plus I. That is fine. And a big if, and if all of that is true, then we have found a set of opcodes that can be removed. And we will need to remove opcodes of this arrow bytecode. And how many, or I minus, how far back would we need to go? So if we poke and then we pop and then peek it, we just need, so I is going to be looking at peek, so it's just I minus 1. It's going to be those 2. Okay. I minus 1, 2, op, offsets, ops, this arrow, annotations. Okay. Changed is equal to true. And then what would we do? We need for I to be, and since we took out 2, minus equals 2. Yeah, all that's the same. It's just our test. Which means we could actually combine these 2 into 1, but that's fine. We can optimize that later. And then last but not least, there's our closing it. Now, what does our if statement look like? It's a bunch of things. It's going to be if that, and that, and that. What are the that's? Well, the first one is op sub I dot first is equal to opcode which one? Peek. Okay. Sorry, I know I'm just thinking. Okay, and this is I minus 1 and I minus 2. Pop and poke. If that's all true, and then last but not least, the targets. Okay, so the targets have to be the same. How do we get that? Well, we have to say, how do we get there? See, we're going through ops. And that will tell us, so ops is what? Ops is the bytecode. Okay, yeah. Ops is the opcode and the bytecode offset. First, and then, yeah, the bytecode offset. So dot second. Okay. And so this is going to be, is it this dot bytecode? I'm in program, so yes. This arrow bytecode of something is equal to this arrow bytecode of something else. So if those two bytecodes, which one? It's going to be op sub I dot second plus 1, right? The next bytecode, okay. And then this is op sub I minus 2 dot second plus 1. That looks right. That looks right. I hit save. We're going to compile, see if I broke anything. Segmentation fault. Whew. I would hate for something to actually come out the first time. Oh. So I want to get this before and after. There we go. And we don't know if it's, well, segmentation fault should be while it's compiling, but it might be, I don't like the way I did that iterator. So, the iterator for the delete is, I'm sorry, that's what I'm thinking. So let's just see what this did. We evidently had a poke, pop, peak. Oh. What if this is in the range that needs to be deleted? And this didn't come out right anyway. Yeah, because that's before. Wait. Yeah. Before then after. That had nothing to do with any of this, just running it. Poke, pop, and peek. I should have gotten rid of the poke and peek. Integer, poke. Yeah, I'm going to do something really quickly. First, this one, I'm just making it a big number, so it won't run at all. Oh, the before probably left off or didn't delete a semicolon. Now, all the tests should pass now because it shouldn't try to perform this optimization. All right. We're going to go up to where we remove the opcodes. After, that's fine. Delete the opcodes from the bytecode array. Okay, I was just looking through, making sure we weren't using bytecode anywhere else. All right, so move any annotations, but we need to make sure that they're that they can be moved. What am I doing? All right, so if I minus bytecode deleted count if it's something. All right, so what am I checking for? I want to make sure that it's attached to something that's still there. So let's just make this an auto new I. New bytecode offset. I don't think I'm using that. Is equal to I minus bytecode deleted count. Okay. And now this can be going to be two things, and then this is going to be okay. That should be fine. Now, what is my test? I want if it is less than bytecode start or it is greater than or equal to, no, this isn't right. Oh, no, I shouldn't be using, well, I can leave the new bytecode offset. But if I itself is less than bytecode start, or I is greater than or equal to bytecode exclusive end, then move it. So in other words, if it's outside of, so if it's inside this range, then we're just deleting it. It's getting deleted. But if it's outside, then we are moving it. Yeah. And because we're always moving back, we're starting at no, wait. So this shouldn't have. Okay, I just did a lot of work for nothing. Because of the way I'm writing my. Okay, I didn't need to do any of that. That was a waste of time. Sorry. So that's not where the problem is. But we'll go back up here. What I don't like is how I'm erasing this right here. The deleted opcode entries from the opcode offsets. I say next is iterator +1. The problem is I'm afraid that, and this is because I don't know enough about iterators, but I think that if the vector has to, say, resize, then maybe the iterators are invalidated. Yeah. So my question is how can I get the index from the iterator? So let me see. Pull up our trusty thing. C++ vector get index from iterator. Because if it would be like just iterator minus the vector begin, would that give me the number? I don't think so, but like that. Oh, wait, is it just saying? Oh, I guess. In that case, C++ vector. Oh, no, wait, I can do that. I know how to do that. So what I'm going to say is auto How about index is equal to iterator minus offsets dot. Oh, but this is a reverse. Begin. So I can change it to say iterator +1 dot base. That should work. Index, okay, and now I should be able to erase the index, and now the iterator will be I wonder if I can do this a different way. If I can just say begin. Don't worry about any of the thing. Okay, so the erase, I should be able to give it the key. Let's just offset. Oh, nope. What are we not liking? Oh, wait. Again, I'm just being stupid because I'm just recalculating the iterator there. And it's probably now not going to like sorry. Okay. Yeah, and now it's not like, okay. This is where I should have just kept that +1 dot, what was it, base? For something tells me I'm just wrong. Offsets. That took a little bit too much brain power. Should not have been that difficult. Segmentation fault. Okay, so I'm going to see out some stuff. I'm going to say number of elements, size, okay. Index is index. And I'm going to say forward index is, and we had to calculate this, but it would be it plus 1 dot base minus offsets dot begin. Is there anything else? And then just the size. That's fine. Okay, I just want to see what's happening. Yeah, I don't think that is correct. Look, my number's gotten really, really big. So why? Because the number of elements is really, really big. I can just do it is equal to offsets dot r end. And it'll just stop after the first one. Or so I thought. In case you're wondering what I'm doing, there. That should be reset and I should have the old code. That all ran. Just want to see how many times it's doing it. is right here. The number of elements is 5. Index is 4. Forward index is 0. Wait. So let's do that again, or count that again. Number of elements, there's 5. What? In offsets? Oh, for the operation. Yeah. This is for the operation. There's a certain set of offsets, and each offset has a, you know, offset and oofset. It's a pair. So what I'm wondering is, I'm just going to add a few more things. Cout op. Okay, so we're doing our number of elements is that. Okay. The backward index is that. The forward index is that. So there's going to be 2. One right after another. Sort of before and after. So the pop, there's 5 elements. The backward is 4. Forward is 0. That should make sense because if the backward index is 0, that means it's the last one. So this is the first one. And it makes sense if the pop that we are removing is the first pop, which, where would that be? It's in there somewhere. Oh, it's with a null. So there's a null and then a pop. There's a null, but sorry. I'm looking at this, but it's the afterwards where it appears. So null val pop, 14 and 15. And is that the first pop? Yes. Is there another pop? Well, there's 1, 2, 3, 4, 5. And then afterwards, there should only be 4. 1, 2, 3, 4. Yeah. So that is correct. There's 5 elements. The backward, we're on the very first one, so the forward is 0. Afterwards, ooh, that's why the backward index is too big now. I was going past the beginning. That makes sense. Okay, so what should it be? We're going forward. Deleted that one. It should be, this is correct. Erase with the forward. Where's index? Oh, index is still here. That's fine. Index minus 1. That should be. What if it's the last one? What if it's R begin? If the iterator is R begin, that's going to be 0. So that's not right. Yeah. Is maybe because it's the last one? Do I delete one where it's the last one? Backward index of 0. Okay. So I'm wondering if it doesn't like that. I think the index number is correct. I'm wondering if well, first of all, let's go back down. All right, so what I'm going to say here is because I've got index, right? And that's the index from the beginning. If I just say index offsets dot begin plus index, and just to show that will be things like the forward index is, oh wait, backward index is index, forward index is what did it show up here? It looks like calculating the forward index is always correct. Okay, so here's the problem. I want it to be begin plus that. If I run that, whoops. Yeah, I realize what I just did. First of all, in setting it to our end, it'll never actually stop because it does a plus plus, so it needs to be rn minus 1. But now, does that mean it needs to be index rbegin plus index minus 1? Yeah, which means all of that messy stuff was probably, all of this was probably just fine, and it just needed to be plus index minus 1. That's fine. Now if I so this may look a little messier, but to me it's more like, okay, so the point of the index is get the that's what it really is. It's reverse index number. Okay. Calculate. Whether or not this is necessary. When a vector erases elements, does that invalidate? If so, then our recalculation is necessary. Okay. Oh, why? Because this should be reverse index. Okay, so we've got that working. It was working before, right? I feel better about the deletion process, though. We're still getting a segmentation fault. Okay. So here's what we're going to see. Cout remove and what are we removing? Offset is I-1. Length is oh, well, 2, of course. In fact, I don't need any of that line. So I can see what's happening. So we're removing offset 7. So 7 is we shouldn't be removing 7. Oh wait. 0, 1, 2, 3, 4, 5, 6, 7. Pop followed by the peak. That's the last 2 items. Pop followed by the peak. And what do we get? We got something that's even longer. Integer 2, 10 poke 0, 12 poke 2, 4. This doesn't make any sense. Because this is the before, this is the after. $14, $15. Yeah, that something's not right. Okay. Notice we haven't even gotten to the part of the check where we're saying if 26 and 27 are not jump targets, right? We haven't even looked at that. So, okay. Okay, that's metadata. This is also metadata. Where's the bytecode? Get it. That's the annotations. Where do we actually change the bytecode? Oh, right there. There should be two afters, the way I'm writing this. I mean, we're just logging stuff, so. Yeah. There should not be more. Why is there more? That's a very good question. If someone is watching this in the future on YouTube, you'll wonder why I'm doing this, but I'm also broadcasting on Twitch, so hi to the person in the chat room. I broadcast on Twitch just to make myself not do other stuff, you know, like you get off track. And but yeah, I am writing a programming language from scratch, really from scratch. And yeah, there's a GitHub repo you can check out. Just look for Tang, T-A-N-G. It's the name of the project. And yeah, GitHub repo, and then on YouTube there's all the episodes. This is, what episode number is this? Episode 85. Yeah, that's where we are. Oh yeah. Python would be easier, but I'm doing this, well, because I wanted to learn C++. And so right now I'm trying to debug something, because basically, for some reason, when I'm erasing something, it's ending up with more. More things. And that should not be the case. So, yeah, that's what I'm trying to figure out right now. And now, so basically you're my rubber duck at the moment. What I'm doing though is I'm basically just verifying the variables that are going in, the values, to make sure that they make sense. That would be a problem. So for some reason, my bytecode start is saying 12 and the end is 9, which means it's negative, which means that would be y. So it's probably a problem in how I'm computing it. So the start is the position dot second, and the exclusive end, exclusive meaning up to but not including, just like every range in Python. My position count is supposed to be how many things I'm doing. So let's log all of this. Well, I already know what the, well, I'm gonna log it anyway. Whoops, not there though. There, so I can find it. So I'm going to continue talking to the person in the chat because, well, why not while I'm typing? So are you still a student then? Let's see, count. That's cool. I actually used to teach. Loved it. I taught classes like theory of computing and discrete math and a few other things. So, why am I saying cout? Count. Should be count. Anything else I need to throw in here? Let's see. Theory of computing is a great class. I've actually never got to take a compiler's class on my own, but if you watch any of the videos, you'll hear me say this. In preparation for this, I'm just doing this for fun. I'm doing it because I think it should exist. Recording a non-trivial project from start to finish, C++, you know, how to set up everything from bare bones, yeah. And yeah, I just thought it should exist. So I decided to make it, and I was like, but I've never written a programming language, and what kind of programming language would I want? So I chose one. Well, that is, I wanted a template language that I could use in some C++ projects that I had coming up planned. So I decided, yeah, I'll just do that. Anyway, and I thought it would be something I could get done relatively quickly, and we could see, and now we see, well, how far I am into this. And right now I'm doing a this is my it's already compiled to bytecode and have a virtual machine executing it, and now I'm on optimization stuff. And right now I'm in a function that basically takes my vector of bytecodes, well, it says remove opcodes, but it's the bytecodes, because an opcode will have a variable number of bytes after it, right? So, but it will take it, and the point is to say, go down to the 7th one and delete 2 of them. And so however much it is, it'll just delete that and update all the metadata. But I've got a bug somewhere, and that's what I'm doing. So, yeah. Okay. So I'll ask where you're going to school while I'm still talking about this. Let's see. So my code is basically my bytecode exclusive end shouldn't be smaller than my bytecode start. So I'm saying is my position plus count, position is 7 plus count greater than or equal to the size. Oh. If it is, then just grab the size. I think this is my problem. Okay, so ops, hey, like I said, you're my rubber duck. This is rubber duck debugging. Or at least I open up every video saying that you're my rubber ducks, whoever watches this, because even if no one's there, I still talk through the problems. So the problem is I see you say you're in the Caribbean, or is it Caribbean or Caribbean? I hear both. Anyway, I did my master's at Midwestern State University, and there's a lot of students from the Caribbean that go there. Let's see. Yeah, but I don't remember which one I said second. Did I Caribbean or Caribbean? Or did I say it the other way? Which accent or which syllable gets the accent? All right. So, okay. So for the rubber ducking, let's see. So ops is it's a vector of the actual opcodes. You get a vector, like I said, it's an, yeah. No, I was just making sure because I've got all of this stuff up here. It is a vector of the opcodes, and so each entry is an entry into it. And so the problem is evidently that it's needing to delete the last one, the last opcode, but it needs to know how long it is, and so it's been assuming it can just take I'm sorry, I know I just stopped talking, but it's because I'm thinking through the problem. Ops is, I'll just type it out. If there's an opcode like pop, right? And then it will say it's a pair, right? And say it's at bytecode position 15. And then right after that, there may be, what are some of them? An integer. And it's at location 16. And then after the integer, because an integer would have 2 bytecode locations associated with it, if it had a pop, after it wouldn't be at 16, it would be at 18. The problem is I'm saying I need to delete, that's right, okay, figured it out. Basically, if this is number 1 and this is well, we are in computer science, it would start with a 0, 1, and then a 2. The problem is I'm saying if my position plus count, so position is which one I want to delete, and let's just say it's 2 is my position, and my count is 1, and I just want to delete that one. The problem is I can't ask the thing that's past it here, I can't ask that for its location because it doesn't exist. And so I said, well, I'll just grab the total size. Well, that's wrong. It should actually be bytecode size. That's, like, pretty sure that's my error. And so I'm just hitting save. It's going to do its recompile. And oh, okay. So is this better or worse? I have a bigger problem. Well, no. Okay. Bytecode before, bytecode after. That is fine. 2725. I think I fixed this problem though. 2826. 2826. 2826. That, I mean, all of these seem. Oh, the reason we're seeing so many of them is because it's working correctly and it's doing a lot of them. Okay, so just search for the next C out. Not that one, not that one, this one. Okay, so I'm getting a lot of this stuff, and there. All I'm doing is commenting out my before and after, grabbing those changes. And I do some rather low-level tricks for keeping track of garbage collected stuff, and that's what this is saying. It's going back to that, but I need to figure out where it's happening. And so, where does that word remove show up? Found it. All right, so I'm not seeing which one it's dying on, but the reason may be because there's one other test here that I had not done yet. So this optimization was, so the virtual machine is a state machine. And the question you just asked, how long have I been working on this? Well, I've been putting out a video a day, and I'm on video 85. So what's live on YouTube is a couple days behind, just because I have them scheduled to come out one a day. So, and I'm trying to work a few days ahead. So even though obviously it's on Twitch, that's the raw, unedited, all my mistakes stuff. Whereas what's on YouTube is not that it's much better, but it's at least cut to length and everything. But anyway, okay, so the virtual machine is a stack machine. I could choose either stack or register, so I went with that. And I went with a stack machine. And so the idea is that a poke it takes something that's on the top of the stack and puts it in a stack position relative to the frame pointer. And then a pop would pop, but it doesn't remove it from the stack, because the pop would remove it from the stack. But a peek will load it to the top of the stack, load something from a frame pointer. So it would be like if whatever's at the top of a stack has a value like a 3, and you're saving it to a, a variable named a. And so that would be poking it into a's location and then getting rid of it off the stack. But then if your very next statement needs to load a, this is the pattern that we're looking for. A poke followed by a pop followed by a peek. Poke, pop, peek. And so that's what this test is. But the thing is I cannot do it. If 26 or 27, so I would be removing in this 26 and 27 because they're not needed. Of course, with compilers, it's the idea of if you can remove something and you get the equivalent result, poking still needs to be there, but popping it and then loading it back onto the stack is pointless. So I could remove both of these unless 27 is a jump target. And I need to make sure that 27 is not a jump target. So I've got all of my possible jump opcodes. Where did I put those? They may be a little higher. Yeah. Oh, and I called them jump opcodes. How nice. Let's move back down and where did I put it? Okay. So just say the optimization cannot be performed if op sub I dot second, but is a jump target. Okay, so we need to go through each of our jump targets. There we go. And is a jump target. Sure. And we'll just initialize this as false and go through and say auto, and now we've got the problem of we have to go through a different array. And just because it's C++, it takes a lot more work. So let's do this. Let's fold that just so I don't have to keep looking at it. Fold that. Folding just so. Actually, what I just closed probably would. Op and offsets. So op offsets is that. So yeah, I need to go through if op offsets. Here, you're about to see it anyway. If op offsets dot count op, and that says if it exists, then for auto ampersand and what is in op offsets We can use the structured binding, bytecode, offset, comma, opcode, offset within offsets dot at op. That's messy, but all that we're saying is for each possible jump target, does this line is does the program have that opcode in it? And if it does, then go through each of the opcode locations, and if the bytecode offset is equal to I, know I just stopped talking, but it's because I'm thinking. You see, it wouldn't be I, because I is it's not a bytecode, it's the opcode number. I need to know where. Oh, it's op sub I dot second. Op sub I dot second. Then is a jump target is equal to true. Can I break out of here? I think so. And just to make all of this clearer, dot first is no. Opcode is equal to ops sub I dot first, and this can be auto ampersand, and then auto ampersand uinteger t, which is a type that I'm using, op sub I dot second. Uinteger t is the name of the type. I don't need to specify it, but it is the bytecode target. Yep. Okay, so for here I can now I still have to keep this because there's no way of getting around it. There's no way of getting around this one. But maybe I shouldn't do that. Maybe that's probably just messier than it needs to be. But it's not bad to have as a sometimes I feel like I have to fumble around with Vim maybe a little too much. Nope, messed up there. bytecode target. Okay. That makes it, well, at least easier to read. And now, jump targets. Didn't I decide that I'd already written that? Jump opcodes, of course. Don't know why I called it jump targets. Because that's declared in a different function. Well, you know what we're going to do? Put it outside the function. Declare it static so that no one else will complain about it. Is a jump target is equal to true. And lastly, if not is a jump target, there. Now I'm using it. Still have an unaligned tcache chunk. Normally that occurs when that is weird. So what I'm going to do, well, first of all, just to make sure, I am missing a dependency. If it did that, I'll have to find that later. A dependency in my make file, by the way. That's what I was saying, or meaning to say. Okay, so it's still happening. So I'll just run gdb on build apps test, run it. When making an error, on the add, and which one am I in? I'm in my control flow while, so I'm going to look at all my tests. Test. There we go. Control. So it's one of these. I know these are ugly. They're just very, very short. wait, we can see which one we're on. We are in the while test. 1178. Which means we are in this test. So it's the very first one. Rerun that test. So what I'm doing is I have a program that will dump the bytecode for this here. And we'll see. So null val is reserving a spot for A, and null val is reserving a spot for B. Integer 1 is the 1. Poke that into A, that's fine. Integer 10, that's fine. Oh, this is the result of the optimization. And what do I mean by that? Well, before it would have done poke that 1 into A, and then it would have popped that result because it's the end of the statement, and then it would have reloaded A here. But 1 is still at the top of the stack. And so it's being saved in A. Then load integer 10, do the less than comparison. That's that right there, less than. Jump if it's false with a pop to 24. So if it is less than, then jump to 24, and 24 is loading B from the stack. That's the comment that goes along with number 24. So that is correct. So that optimization was done correctly, at least I think. And now, let's see. If it's not false, keep going. And this is where we peak 0, which is A, integer 1, and we call add. And it's in the add that it is, that's the only add. And in fact, so I'm going to rerun the GDB. We'll see it's in the, in the add. See, we're getting operator plus being called. Program.execute. All of this makes sense. And then we're calling new. And this is where we're getting the unaligned tcache when we call new. I've never had this error before. Well, not since this has been working and we didn't change the garbage collected stuff. So if I look at it's making an error, and that is, wait, why is it making an error? this should not be happening. So when it calls add, the operator plus, it should not be calling the computed expression add, because the only place the add is happening is right here when we've peaked 0 and integer 1. Yeah. And peak 0 is what we poked in to 0, which was an integer 1. I wonder so I'm going to edit our program execute. Because all that I want to do is, I want to know what bytecode we're on, because I think I know which one. I just want to know for sure. So, cout, this is a new program, that's fine. And then, for each one of these, cout, the program counter is PC. This may be ugly. Yes, quit. This is a lot more than I anticipated. So this is the, ignore the top part, this is the bottom. 0, 1, 2, 4, 6, 8, 9. 0, 1, 2, 4, 6, 8, 9. 11, 13, 15, 11, 13, 15, 16, 18, 20, 21, jump to 6. Okay. I think I know what the problem is. So that jump to 6 is the end of the while statement. There we go. And the while statement is this b is equal to a plus 1. So what it's doing is I'm basically a is equal to a plus 1. It's testing the order of operations and whether or not that's assigning it to b. And so a is just incrementing over and over, but when we're done, b should have the value of 10. Okay. So the thing is reloading this one should not have been optimized away. I mean, that's a problem. Okay, so when we jump to 6, it's just loading integer 10 and then saying, and less than. Get the less than. The problem is there's nothing to less than the 10 against. It should have loaded a. But this was optimized out because of the poke. Yeah. So the question is why didn't my test work? Why didn't, when I was writing something to protect against that? So for each one of the jump off, oh, because so for each one of these, because I wrote the test wrong, the bytecode offset is where the jump is, but what I'm wanting to make sure is that bytecode offset +1. That's what I need to test against. So bytecode offset is where the jump that is where the jump opcode exists, but the byte following that is what I want to make sure doesn't match the ops_i.second. What is ops_i.second? That's the bytecode target. So right hand side, redo the test. All of my tests passed. And now I've just got a lot of stuff here of program counter recording that. So let's remove that. And that means we're almost to a stopping point for today. Let's see, B4. Remove that C out, that C out. No, don't quit. Normally, over here, I've got my test.swatch. There we go. And now my tests take out the fact that I was printing out the bytecode. All right. Do we ever apply this optimization? I want to find out very, very quickly. So that's just letting me know that yes, one was actually changed. And all the tests are still passing. Yeah, okay. So we found a lot of places that we could apply this optimization. All right. I am happy for that. Okay, so now we've got there. I'm leaving in all of the commented out code just because I'm using it for debugging, and this is like I'm on number 3 of 4 for bytecode optimizations. So I'm going to leave there. And we can also remove all of these maybe unused because we're using them all and it's just cluttering up everything. Everything should still compile, we hope. All right. And we have unsaved changes in here. Anything else? So over here, my customary do a completely fresh installation, or not installation, but compilation, just to make sure everything compiles, all my tests pass, while at the same time I'm going to look at my git commit. All of this looks correct. All right. For poke, pop, peak, pattern. Oh wow, that's what I should have called. Put it in the title. And yes, all of my tests are passing. Okay, it's a lot of work for only an additional 40 lines of code. Not get. Make docs PDF, and this will update our documentation. Yep, just a little bit of changes. So git add docs. And which episode are we on? I know I said that earlier, but I'm old and forgetful and I don't remember. Episode 85. There we go. All right, so it has been pushed up to GitHub and tagged with episode 85. And the last thing we normally do is just check out where our lines of code are sitting. We're at 11,000 lines, almost 11,500 lines of code, 3,700 lines of comments. So that's not counting the blank lines. Again, lines of code does not guarantee code quality or anything else. It's just, it lets me kind of know how much work I put in. But with that, I think I am going to finish up. And to my visitor in the Twitch chat, thanks for dropping in. I try to record a little bit every day, and not at a set time though. But and to those of you who watch this later on YouTube, thanks for joining in. And we'll be back, and the next episode, of course, we'll be working on the next bytecode optimization. And once we get those three, there's a few other things that we can attack to help our code be more performant. So to increase our optimization. So that's what we'll be doing. So thanks again, and have a great day. Bye.